Hello everyone. So today I decided to make for you a video for the reverse FMEA. So as you know, recently a lot of OEMs are starting to request to implement and to conduct the reverse FMEA, but unfortunately there is not yet enough, let's say, references or books that are describing exactly what you have to do in this reverse FMEA. So today I decided to make for you this training video to explain to you all what you have to do based on my experience in the automotive industry and based on the huge amount of the reverse FMEA I have already conducted before, and the customer was very satisfied based on the results and on the steps I have followed previously. So let's start. So in this training, we will see the definition of the reverse FMEA, then we will see the purpose, so why we will do the reverse FMEA and why we will perform the reverse FMEA, and we will see what the OEMs or the customers are requesting. So we will see the example of Renault, Stellantis, General Motor and Ford. Then we will see the benefits of the reverse FMEA, how to perform the reverse FMEA, and at the end of this video I will explain to you step by step the 9 steps, let's say, how to make the reverse FMEA exactly. So if you follow me and if you follow those 9 steps, you will have a great, let's say, result on your reverse FMEA. So at the end of this training, you will be able to conduct by your own team the reverse FMEA in your production or in your process. So let's start. Firstly, we will see exactly just a short definition of the reverse FMEA. So the reverse FMEA is a structured process of continuous improvements that aims to ensure the permanent updating and progress of an FMEA. So as you know, the majority of the people, when they are making the reverse FMEA, when they are making the FMEA in general, they are not updating it frequently. So the reverse FMEA, it allows to you to go whether once a year or twice a year to go and to make the update of your FMEA. So this risk assessment method is based on reality and not predictive reliability. Why this, let's say, this phrase? Because when you are building your FMEA, it's not based on reality, it's just based on assumption, experience, lessons learned, previous projects and so on. So you are just pretending and you are just making some assumption, what can be the risk, what can be the potential failure modes and so on. Then you are starting to build your FMEA, but the reverse FMEA is based on reality, on shop floor, on the production, on what is happening right now in your process. So the purpose of this training is to introduce you the way to perform the reverse FMEA at your plant. So let's see somehow some purpose. So the reverse FMEA validates the quality system is in place and functioning properly based on the PFMEA and control plan. It means that when you are making the FMEA and you are implementing this in the process after the production is running, you have to go in your process and to check if what you considered previously as control plan, as detection mode, as let's say severity, as risks and so on, is it exactly what is right now in your production or not? So it's like you are making an audit, or it's like you are checking exactly if what is in reality is matching exactly with what is in your documentation and what you put as assumption in the beginning. So the reverse FMEA compares the manufacturing system as designed to the way the manufacturing system actually functions. What's happening here is that when you are building your FMEA, sometimes you don't have even the machines, you don't have even the process. And after you implement the process, when you start the production, sometimes you find out that there is something which is not, let's say, a good. Sometimes you have to add some reworks, sometimes you have to add some firewalls and so on. The problem here is that when you are starting to add these new stations, you are not thinking to go back to update the FMEA. So when you are making the reverse FMEA, means that when you are going to your shop floor to check exactly what's happened, sometimes you are recognizing that there is some new process, new operations, new steps, new sub-steps, missing process, and so on. Then when you are comparing with the reverse FMEA, sometimes you find out that you are missing this new process or this new operation. Then you have to start to think what we have to do, what are the risks behind, and so on and so on. So this is exactly the purpose of the reverse FMEA. So let's see the third step. So the reverse FMEA is engaging cross-functional expertise to review the PFMEA in detail, looking for any errors or missed operations. So this is one also of the purpose. It's to engage the cross-functional team. So it's not only the quality, it's not only the process engineers that should be involved in the reverse FMEA, but all the cross-functional team. You need the knowledge and you need the skills of the whole cross-functional team and departments in order to see and to recognize and to detect and to find out new errors, new potential failure modes, and new risks. So this is the purpose, let's say, of the reverse FMEA. So why we are performing the reverse FMEA? So the reverse FMEA are nowadays getting used extensively in the automotive industry to meet customer specific requirements. It's the CSR. So now, recently, as I told you, many OEMs and many customers are starting to request their suppliers and their sub-suppliers to start to implement the reverse FMEA. So let's see here some of the OEMs, what they are saying in their CSRs. Let's start by Renault. So Renault said the supplier shall review FMEA by using the reverse FMEA tool and make this tool deployed over its tier 2. It means that you have to use the reverse FMEA to review your FMEA, and you have also, if you are the direct supplier of Renault, you have also to, let's say, to push your supplier, which is the sub-supplier of Renault, to implement it. So it's not only you have to implement it, but also your supplier should start to implement the reverse FMEA. So the supplier shall review the FMEA by using the reverse FMEA tool in order to switch from corrective to preventive actions. The supplier shall check at shop floor level. So let's stop here. At shop floor means it's not in the office or it's not in the meeting room. It should be in the shop floor level their existing FMEA and provide necessary activities to avoid occurrence or at minimum to improve detection if non-conformity. So here Renault, let's summarize, they are requesting you to make the reverse FMEA, to require your supplier also to implement it. They are requested to do it in the shop floor, not in the office or in the meeting room, and they are requesting to do it in order to avoid the occurrence or at minimum to improve your detection. It means whenever you are going, maybe you find out that the occurrence you have defined previously it's not the same or it was changed and so on. So you have to detect some new, let's say, things to be improved or some preventive, let's say, actions. Stellantis, let's see Stellantis what they are saying. They are saying that the supplier must implement reverse FMEA to identify new potential failure mode in shop floor. Proactive risks reduction process, confirm or update current occurrence detection levels. The reverse FMEA is an on-station review by a cross-functional team. So also they are emphasizing that the reverse FMEA should be in the process, on station, by cross-functional team, and also it should detect new failure modes if it exists. Let's see here also General Motor. So they said that the organization shall have a process for effective review of PFMEA of all manufacturing parts and process to occur annually at minimum. So here General Motor, we see that they are defining the frequency. PSA or Stellantis and Renault, they didn't define the, let's say, the frequency, but here General Motor, they said at least once a year. So let's continue. This review shall consider at a minimum critical safety and high risks items. The organization shall incorporate tools such as reverse FMEA or other similar methods to assist in the PFMEA review. So it's more or less, it's the same purpose but General Motor they add something which is new, which is, let's say, the frequency of the reverse FMEA. Let's see now Ford. It's one of the best definition, which is including all the things regarding the reverse FMEA. I really like the definition of Ford regarding the reverse FMEA. So let's read what Ford are requiring. So this said, organizations are required to have a process in place that ensures all new launches complete and reverse FMEA events once the equipment is installed and running. So they are asking here not after 1 year of the production, but for every new launches. And once you install the equipment, you have to be sure if what you defined in the beginning it's exactly what you implemented after you bought the machines and you start to implement them in the shop floor. This process should be first completed at the equipment manufacturer and then after final installation on the supplier plant floor. It means that you have to do the reverse FMEA, let's say, before or during the development of the project and just after the implementation of the machines in your process on your shop floor and just after you start running the production. Let's continue. The reverse FMEA involves design and process engineers working with operators and attempting. This is the best phrase that none of the others, let's say, specify this. Attempting to make bad parts, beat the error proof, and find new failure modes. The purpose of the reverse FMEA it's not only look and check and checking the mismatching and checking the coherence between what is in the process and what is on the documents, but also you have to challenge and to attempt to make bad parts and to challenge your error proof. This means that you have to take some bad parts and put them in the process and see if your error proof, if your Pokayoke well detected or not. Don't trust your Pokayoke and say, yeah, I have here this Pokayoke and it works well and so on. No, you have to challenge it. You have to beat the error proof and try to pass some NG parts and to see if your process will detect it or not. So in order to find obviously new failure modes, causes and develop controls. So the goals is to discover opportunities and implement improvements in the FMEA that were not previously discovered. So this is the best definition that is describing all, let's say, the activity of the reverse FMEA. So here I put here one matrix which is summarizing the requirements, the objective, frequency, actions, and the team for every OEMs. I will post this in the presentation and I will share it with whoever needs this presentation later on. So what are the benefits of the reverse FMEA? So the systemic application of the reverse FMEA tool brings many benefits to the company such as, so the first one is to gain experience and knowledge of the production teams. This means that when you start, let's say, the production and when you start to build the team, many of your team, the quality process, sometimes they don't even know the machines, they don't even know the process and the product. So when you start to implement the reverse FMEA, they start to build their knowledge because they are going deeply in details to ask questions, to challenge the Pokayoke, to understand the PFMEA, to understand the control plan, to understand the process. So then, based on that, their knowledge, it starts to be growing. Secondly, one of the benefits is to maintain, review systematically and improve the FMEA. As I told you in the beginning, many organizations, they are just implementing the FMEA in the beginning of the project and they forget to make systematically improvements and updates. So this is opportunity or benefits from the reverse FMEA that allows to you every time to make this update and this review. Third benefits is to reduce risks and costs of no quality. So this is obviously, it's whenever you are finding a new potential risks or new potential failure modes. So it's a potential, let's say, customer claims or recall or something like that. So obviously it's to reduce the risks and cost of no quality. The fourth benefit is to build a structured knowledge base, and the last one is to improve the production process. So let's see now how to perform the reverse FMEA. So the reverse FMEA is an activity where you begin out on the line at the actual point of work and work your way backward to validate the FMEA. So here it's this is a bottom-up event that provide validation and real-world applicability to the FMEA. So if you see here, in your PFMEA, in the beginning, you are always starting by in the, let's say, in the meeting room, in your desk. So you start by the documentation to collect the design FMEA, drawing, customer specific requirements, process flow chart, and so on. Then those all documents are the input of your PFMEA. After your PFMEA, you are creating the control plan. After the control plan, you are creating the work instruction. Then you are starting to implement all those documents in your workstation. But regarding the reverse FMEA, you are starting in the opposite way. So you are starting from the workstation, you are checking all what's happened, then you are going back to update your documentation in case you find out any, let's say, potential risks or potential failure modes or any errors or gaps. So for this reason it calls reverse, because you are doing it in the opposite way of the PFMEA. So the team walks to the floor and verifies that the production process matches the process documentation and all gauges, error-proofing devices, documentation, training, etc. are in place and functioning properly. So you have to go to the process and see what's happened and check with the documentation. So you have to look for every station and take your process flow, your PFMEA, your control plan, and try to compare. Is what you defined in the beginning exactly reflect the reality in your process? So the team should identify any operation that is not a part of the production process, such as repair, rework, and validate that they are properly called out on the PFMEA. Sometimes when the production started, sometimes we have many issues and you start to decide whether with the approval of the customer or without. You start to think, for example, to make the rework if you have a high amount of scrap. But when this new rework, this new station has many risks, so sometimes no one goes and let's say think and introduce this one in the PFMEA. Even you have to do it in your process flow. So when you are walking, sometimes you are recognizing that, yeah, we have this rework, but it's not defined in the process flow. Means that it's not in the control, means that it's not in the PFMEA. It means that it's not in the control plan. So all this activity of rework, it's not in the control, which is representing a high risk of your activities. So this is one of the things that you have to recognize during your reverse FMEA activity. So the team should verify the standards are being followed and identify any areas of potential quality risks to the customer. So now let's go to the 9 steps on how to perform the reverse FMEA. So I defined for you 9 steps. If you follow those 9 steps, you will have a good result of your reverse FMEA and all the customers will be satisfied. So the first step is to identify the scope. Second step is to form the team. The third step is to review the documentation, then to work through the process. After that, identify gaps and risks. The step 6 is to create an action plan. Step 7 is to update documentation. Step 8, complete lessons learned. And step 9 is to track the implementation. So let's see one by one right now. So the first step is to identify the scope. So the team should identify firstly the scope where to make the reverse FMEA. So which project, which process, which customer, identify the customer specific requirements and so on. So before to start, you have, it's like a project. So you have to define the scope of your design of your reverse FMEA. You have many process, many products, many customers, many plants, and so on. So obviously you have to make such a planning of your reverse FMEA. So this amount I will do it for this project, for this customer, for this process, for this plant. And these are the team that those are the team that will let's say help me and assist with me during this reverse FMEA activity and so on. So you have to define the scope of your reverse FMEA activity. Secondly, you have to form the team. So as I explained to you before, this is requested some cross-functional team with such expertise. So but before to do it, obviously you have to form and to train the team and to build the team for every area. So we need process engineering that are, let's say, high, let's say that they have skills in the process. We need quality, we need a lot of people. But those people, for example, if they don't have knowledge of the FMEA, so how they will control it based on the reverse FMEA? So at least they have to have the basic knowledge of the process, of the FMEA, and of the reverse FMEA, how to conduct it, which is a part of this training. So you have to form the team and to build the team in order to have a good result at the end of this activity. The third step is to review documentation. So before going to the shop floor, the team should firstly check the availability of all documentation, because what are the documents we need? It's all of them. So we will need the process flow chart, the PFMEA, control plan, work instruction, drawing. So all the documents, we have to be sure that they exist and all the team have those documents in their letter, whether in papers or in Excel format or in their laptop, but at least they have to have all those documents. Secondly, you have to check if all documents are into the last and the same revision. This is one of the most important things in this third step, because sometimes you have a lot of revisions. The process engineer will bring with them the last revision, which is 6 of the PFMEA, and the quality will bring the last revision, which is 5. So then they will go to the shop floor, they don't have the same let's say revision, and they will start, let's say, to discuss and to waste time if they highlight, for example, any risk in the reverse if in the PFMEA version 5, but it's already included in the revision 6, so they will just lose the time. So please be sure that all the documents will be in the last revision and with the same revision. So then you have to print all those documents in order to be checked in the process and create a checklist audit to be used in order to help the team to find out the gaps and errors. I will show you later on one small checklist that I can help you just to start, but it's not, let's say, the final one. You have to build a checklist based on your process. The checklist, it's not required, but it will help anyone to go deep in details to find out the potential, let's say, failure modes. Because if we give to anyone the documentation, PFMEA and so on, and we will ask him, okay, go please to the shop floor and check if there is any potential failure mode, they will just look to the document, look to the shop floor, to the process, to the machines, and maybe they will not find anything. But if you give to them some structured questions, maybe they will go let's say clearly in to the point to find out the risks. So the fourth and the fifth step is to work the process and identify the gaps and risks. So this is the main activity or the main let's say step of the reverse FMEA. So the team should go to the process in order to firstly cross-check between what is currently in the production versus the documentation. So you have the documents and you have to check. For example, in the control plan, you have the frequency of the control 100%. And when you went to this operation 01, for example, you find out that this operator or this worker are checking the part by sampling, by one part every hour or something like that. So it's not the same. Imagine, for example, that you have in your control plan that the parts should be measured in the CMM, and then you find out that the operator or the worker are measuring using the caliper. So it's not the same. So you have to check between what is in the documents and what is in reality in your production. Then you have to check if there is any potential risks which is not defined in the PFMEA. Here you have to look. You need your expertise to see if you can detect any potential failure modes. Maybe it's something which is easy to be detected. Imagine that someone is taking the parts from the machine and there is some edges, and every time he is touching, for example, the parts with some edges, so obviously there is a risk here to damage the parts, or if the boxes are not clean, or they have dust inside and something, or they cannot close it. So you have to go and to recognize and to see if you can detect any potential failure modes in the process. And the third point here is to challenge the Pokayoke. This is one of the very important things that I am emphasizing you have to do during your reverse FMEA activity. You have to go and to challenge your Pokayoke. Don't trust your process. The main, let's say, task is to challenge the Pokayoke. Take Notoke parts and put them in the machine and see if your error profile and your Pokayoke will detect this, let's say, NG parts or not. Then you have to check if there is missing or additional operations, as I told you. So you have to take your process flow and check if all the sequences of operations are the same that you have in the process flow and in your PFMEA, or you have some missing or additional operation. Then you have to check if the occurrences defined in the PFMEA are coherent with the data of the scrap. Here, it's very important this point, because when you are building the PFMEA, you are putting just some estimation in your occurrence. It's not the real data, but after, for example, 1 year of production, you will have a real data of scrap. So then, and Pareto. So then you have to check if the occurrence rate you put in such a problem in the PFMEA, it's exactly what is reflecting the reality or not. Imagine that you in such a dimension you are putting that the rate it's only 1. But when you are, let's say, checking in the production, maybe this dimension it's one of the top Pareto and it has, for example, 3% or 4% of the scrap. So obviously your PFMEA will be changed. So please to check also the occurrences here based on the scrap. And the last thing is to check if all the K product characteristics are under control. Here we are talking about all what is safety and all what is functional. So here I will, let's say, give you an example of the checklist that you can use during the conduction of your reverse FMEA. So for example, here you have some questions. As I told you, you have to develop it more. I put it just some 16, let's say, questions, but you can do more based on your production and based on your process. For example, here the first question is list any potential failure modes that are not identified in the PFMEA. So here it's based on your expertise, based on your eyes, on your detection. So here you are going in the process and you are looking to see if you can detect any new potential failure modes that can be in the process and was not in the PFMEA previously. The second question is review detection controls to determine if still valid and effective. For example, as I explained to you, imagine that in your control plan you defined the caliper but as let's say variable control, but when you went to the production you find out that they are using, for example, a gauge go no go, which is attribute control, which is not the same. So here you can detect that it's not the same, let's say, detection mode, and you have to put here your observation. The third one, confirm machine calibration is up to date, verify the standard work instruction has correct content, confirm visual controls reflect good bad boundary samples, confirm process design. If there is a special characteristic on the control plan, does the standard work instruction list it correctly? Confirm that the control plan process flow chart frequencies are sufficient to protect the customer. Verify that the process chart matches the control plan. Verify also that parts cannot be loaded nor proceed incorrectly. Check if there is missing or additional operations, and so on. So here also you have to check and challenge the Pokayoke if they are working properly. So you have a lot of questions that you can, let's say, help you to check, or help your team to check and to do it, let's say, in the correct way. So whenever you find out that something which is not good or not correct, so we have to put here the observation. So every observation it become it becomes a new, let's say, potential failure mode which should be included in the PFMEA. So let's go now to the sixth step. So after finishing your reverse FMEA in the shop floor, then you have to go back in your offices and start to create the action plan for every observation or for every gaps. So after completing the audit in the shop floor, an action plan should be created and followed for all the gaps, errors, and risks found. So the global action plan should have a pilot who will track and follow up the progress with the team. Every risk, gap, or error should have at least an action plan. So every action plan should have responsible and due date. So after creating the action plan, you have now to start to update the documentation. So it depends of the observation you see, it depends of the risks you see. Imagine, for example, you find out that there is additional operation which is rework. So you have to go back from the process flow chart. So you have to update the process flow chart to include this operation. Then you have to start to analyze what are the potential risks and potential failure modes for this operation, and then how to control it, and so on and so on. So it depends of the risks and gaps you have found, so we have to update the documentation accordingly, whether the PFMEA, the control plan, the process flow chart, and so on. So after updating the documentation, the next step is to complete the lessons learned. So after all these activities, obviously you will find out some errors, some gaps, some mistakes, and so on. So we cannot let it like that, but we have to build some lessons learned from that. So a list of lessons learned should be created and followed according to the issues that has been detected in order to avoid them in the future. I will give you just here a short example. Imagine that during the shop floor audit, the team found many times that the sequences of operations are not matching with the sequences of the PFMEA, and some key product characteristics are missing. So after they analyzed what are the root cause and so on, they found that the team take the PFMEA from another project that looks the same and apply it in this project, which is obviously incorrect. So as a lessons learned, every new project, the team should create a new PFMEA based on the design FMEA drawing and customer specific requirements of the project, and stop making copy paste. So this is just an example of the lessons learned. The last, let's say, step is to track the implementation. So we have a lot of implementation. You have the action plan, you have the updates of documentation, you have the follow-up of the lessons learned, and so on. So obviously you have to track the implementation of all of that, and I am recommending to you that you should have a pilot of that, whether the project manager or the project leader, or if you have FMEA coordinator, maybe you can give these tasks to the FMEA coordinator to check and follow up the implementation of all of that, because it doesn't have any sense to make all this, let's say, to put all this energy and to make all this activity, and at the end there is no one who is following the implementation of all of that, because the purpose is to improve the situation, not just to make some records and to put them aside. So the pilot should organize meetings with the team to check the status of implementation, send reminders, for example, to the responsible asking for the update, receive the status and track them in the follow-up list, and create and share frequency reports with the manager. Like that, every time you are finishing a reverse FMEA, there is someone else behind who is following all the implementation, and like that you have every time improvement of your process. So I hope that this video will help you to conduct and implement the reverse FMEA in your process. So good luck and see you next time. Bye.